This video will show you how to calculate the rate on a compounding problem. In particular, we're going to compound continuously. So a promissory note will pay $50,000 at maturity 6 years from now. So this is going to be the future value of that note, or what we call A. If you pay $28,000 now, so this is the principal or the present value of the money for the note now, what rate compounded continuously? And you're looking for R, and you know you're going to do it continuously. So the formula we're going to use is A is equal to P E R T. Would you earn? So plug in what we know. We know the future value is 50,000. That's equal to the P, which is 28,000. E. We're looking for R. We don't know R, so we'll look for that. And we know our T is 6 years, so that's R. Let's write like this, 6R. So again, we're given the principal and the ending balance. So we always divide by the principal first. So divide this by 28,000 on both sides. So I have 50,000 divided by 28,000. And I get 1.7857 and a whole bunch of numbers after that. Remember, this is just a visual representation of that number from our calculator, but it's not the accurate answer. We're going to use the answer in our calculator, so we'll just write it out like that. And that's equal to E to the 6R. Now, if I want to get rid of the E, again, this is the exponential, I'm going to use the natural log. And so I'll do natural log to both sides. So I'll say the natural log of 1.7857. That's equal to the 6R natural log E. Natural log and E will always cancel each other out. They're inverses of each other. So I'm left with this 6R is equal to that. So I'll divide both sides by, I want to get R by itself, so I'll divide both sides by 6. When I do that, I get R is equal to the natural log of the number that's in my calculator, 1.78571428.6. So I'll do second, or I'll just do natural log, and I'll do second, and I'll do my recall for my answer button here. Remember, that was on the negative key. And I'll divide that by 6, and I get a rate expressed as a decimal as 0.09, and we'll round to 3 decimals, 0.097. So this is about a 9.7% rate. And so this is what we call this is how you find the rate by using the logarithm again, or the natural log again, all right?